Hello, 8th graders. Mr. Cavey is back with another question from our pre-quiz on this unit on linear equations and relations. Now our learning target, we've moved into 6.3a. We're looking at models of equations. So our target says I can model and solve equations in these formats: ax plus b equals c, or x divided by a plus b equals c. Now, you don't have to remember those formats. That's just the learning target to sort of make it clear what kind of equations we are solving and modeling. So we're looking at these models. I won't ask you to draw out these models, but I will ask you to sort of interpret them, and that's what I'm going to help you with right now. So we're going to start with this problem here. We've got 4 negative x's, so we're going to write negative 4x plus, and I wish they made this more clear, but these tiles here show us that the red ones are positive, so we're going to say plus 7 equals, and we can see here these white tiles are negative 1. So this is negative 1. Maybe I'll give myself more room over here. Okay. Now, where do I go from here? I know that I want to get rid of this positive 7 because ultimately I want to get x by itself. So watch what I do here. Negative 4x plus 7. That's a reminder for me. Plus 7 minus 7 equals negative 1. Now, because I did negative 7 on the left side of the equal sign, I've got to do the same thing on the right side. And this is what I'm left with. So I'll keep going. So you'll see I added negative 7 to the left side. I added negative 7 to the right side. And let's keep going with this equation. So now we have negative 4x equals, and notice plus 7 and negative 7, that just becomes 0. They cancel out. Equals negative 8. And I can see my Grammarly icon is distracting you here, but negative 1 and negative 7, think of putting 8 of these negative 1 tiles together. That gives us negative 8. Let's keep going. How can we get rid of the negative 4? We're so close to getting x by itself. How can we get rid of the negative 4? What we want to do is divide each side by negative 4. So negative 4x divided by negative 4. And I'll put this part in brackets, negative 4, to show that I'm adding it, equals negative 8, and again in squigglies, divided by negative 4, and watch what happens. So I've got this negative 4 here and the negative 4 here cancel out. I wish I could draw them properly on top of one another, but negative 4x divided by negative 4 equals just x. I hope that's clear. I almost want to cross these out, but boop and boop, those two cancel out. And negative 8 divided by negative 4 equals 2. When a negative is divided by negative, you get 2. All right, let's move on to our second problem. In this one we have v over 5 plus positive 7 equals negative 3. Next, how do we get rid of this 7? We're going to subtract 7 from each side. So we go v over 5 plus 7 minus 7 equals negative 3. And then we have to do the same thing on this side, minus 7. All right. And then we've got, okay, so this positive 7 and negative 7 cancel out, so that gives us v over 5 equals negative 10. Remember, you've got negative 3, that's 3 of these tiles here, and negative 7. That's just adding a 7 more. That gives us a total of 10 negative tiles. That's the nice thing about tiles. Now, how do we get rid of the 5? We're going to actually multiply. So in this case, it's v divided by 5. We do the opposite operation to get rid of it. So we're going to multiply v. So I'll just write v over 5 multiplied by 5 equals negative 10 multiplied by 5. That gives me v equals negative 50. Is my process correct there? I believe it is. We'll find out tomorrow. Someone will let me know if I went astray here. I think that's correct. Last one, we've got negative 2 equals negative j over 4 minus 3. Lots of negatives. I know that is frustrating, difficult to deal with. So we've got j over 4. We're going to get rid of this negative 3 because we want to ultimately get j by itself. I think I said j. It's negative j over 4. So to get rid of this negative 3, I'm going to add 3. That's the opposite operation. So I've got to add 3 to both sides. So plus 3 equals negative j over 4 minus 3, and then I add the 3. Okay, so let's take a look. I wish it would stretch out the first time, but it does not. Okay, so I'm just going to solve this. Negative 2 plus 3 is 1. That's on that side of the equal sign. And then we've got negative j over 4. And then negative 3 plus 3, these 3's cancel out. So it's just negative j over 4. We're almost there. How do we get rid of the divided by 4? Negative j divided by 4. Well, we need to multiply both sides by 4. We're doing the opposite operation, just as we did over here. We're going to do that here as well. So we're going to multiply both sides by 4. 1 times 4. Just stick them right together like that. And then negative j over 4 multiplied by 4. Yeah. So we've got 4 equals negative j. And a way to express that, it would be j equals negative 4. Now, if you got this far, 4 equals negative j, I would probably accept that. It's good to state the variable in the equation as a positive, if possible. So j equals negative 4. And again, I'm just going to go back and show you where I canceled some values. So these two cancel out. These two cancel out. And so on. That's how we isolate the variable. All right, I'm going to leave this problem here.